Okay, so today we're going to go through some of the concepts that we learned about polarization in lesson 8 and kind of review a little bit before lesson 8. So polarization is basically the separation of charges. Fitting the theme of this unit, we are going to be doing it with lightning, just in case maybe you missed that day or just as a refresher of what happens. So in the clouds, there's a lot of friction. This friction comes from ice crystals and water particles colliding with each other. And just like when you rub a balloon against your head and that has friction, you will have friction occur in the clouds that will cause a separation of the particles. So those water crystals, more often than not, will take the positive charges towards the top of the cloud, versus your rain droplets will take the negative charges towards the bottom. Now note that they're not just taking, or they're caused by a negative charge by having more electrons than protons in this area, versus the top is going to have more protons than electrons. And that is again because these guys donated their electrons to these water particles right here. So this is a polarized cloud. You have positive charges at the top and negative ones at the bottom. Now, if you have too many negative charges at the bottom, because negative charges repel, right, like charges repel, that they're going to become really unhappy. And they're going to try and find somewhere to go that is going to make them happier. Now, again, like charges repel, so that means opposites attract. So they're trying to find somewhere that is going to either have an opposite charge to them or no charge. They're okay with neutral. So we're going to have the ground in this case. You can do this with metal, but this is a little bit further into our unit. So I'm going to have these electrons will travel down and strike the ground. So again, they're trying to get away from each other because they don't like to be next to each other because they're repelling. And that causes it to go towards the ground. Now, going with this particle view, we're going to be looking at the particles in the ground. So I'm going to just say, for example, the ground is going to have a particle, a normal particle that looks like, we're going to say it has 3 protons, 3 electrons, and 3 neutrons and 3 electrons. Okay, so my negative charges are my electrons, my positive charge is my protons. If they were asking you to draw a model at a particle view, you could technically pick any atom. You could do 1 positive charge and 1 negative on the outside, unless they specify it. It doesn't matter. It's just to try and show the concept that they're asking. So this one might be asking what is polarization at the particle level, or show polarization of the ground particle at a particle level. So when I do this, I have to keep in mind that likes are going to repel and opposites are going to attract. Now, unlike the cloud, which is what we call a conductor, so it can actually move its electrons, like water particles can actually have its electrons move from one particle to another, the ground is an insulator, which means that it is not going to have its electrons move as easily. So instead of being able to fully put them onto another atom or fully push them down, these guys aren't able to get rid of them. So their atoms still have to have their electrons attached. Think about this as like a student in a classroom, right? You are stuck in my classroom for second block. You don't get to leave my classroom, you are stuck. These electrons are stuck. So that would be like an insulator. But after school, you'd be more like a conductor. If you didn't want to be in my classroom anymore, you could go to Miss Littrell's classroom, or you can go Mr. Vasky's classroom, or you could go to the other side of the school if you wanted. That would be more like a conductor. But I digress. You are an insulator, or the ground is an insulator, which means those electrons are stuck on that atom. Okay, so when I draw my atom, my protons and neutrons are still going to be in the center. Why? Because that's a property of an atom. Protons and neutrons are in the center no matter what. In this class, you will not move them until we get to Unit 5, if we get to Unit 5. But what we can do instead is we can show that our electrons that are on our atom are going to shift. And again, they're going to shift because of these properties of physics, which say likes repel and opposites attract, as well as there is an electric field anytime you have two charges interacting. So we have a negative charge here, and then we have our positive and our negatives of the atom and the lightning. So the electric field is going to cause the negative charges to repel each other. So that means all the electrons that are normally just randomly around our atom for the ground are going to push to the opposite side. I'm going to draw them kind of sideways, that way you can see them over my electron cloud. So they're going to force them to move. This is induced polarization. Because you have a charge coming into contact with an atom, it is going to cause that atom's electrons to move to the other side, causing that separation of the charges. No longer are our electrons going to be just randomly around it. They are now being pushed to the opposite because like charges are repelling. This is also going to cause there to be a better attraction, or an easier attraction, between our protons in the center of our atom and the electrons from the cloud, from the lightning. Now, again, if you have a particle interacting with another particle that has a charge to it, you're going to have this electric field, you're going to have this attraction. If for some reason, though, you didn't have the lightning and there was no charge interacting with the ground atom, it would just stay as normal. There would be no polarization because there's no electric field in play.